Let's do a quick walkthrough of the framework. You can run two different files, run graphical game or run text game. So if I run the graphical game, it should look like this. And you can click in individual locations to display the location number you clicked in. The text game is going to be the exact same game, only it's a text-only display. It looks like this, and so instead of clicking, you have to type the row and column you want to move. So here, if I move in row 0, column 3, well, we didn't actually tell it to move yet, but it knows that I clicked in row 0, column 3. And then if you type quit, you can quit. So let's talk about what the different files in the framework do. You may remember that we talked about model view controller as a way of organizing larger programs. If you don't worry, because I'm going to tell you right now. The idea is that there are roughly 3 different kinds of tasks that your program needs to be able to handle in order to run. There's the model, which is all of the information that your program needs to manage. It's the data. For our particular games, that's going to be things like where are the pieces on the game board, how large is the game board, how many turns has each player made, who's winning, that kind of stuff. The view is all the code related to how things are going to display to a user, how things are going to look. And then the controller is the thing that actually controls the process of the game. But mostly that involves handling user interactions. So when the user clicks somewhere, the controller is what decides what's going to happen depending on where the click happened. So usually the controller class is the one that you would actually run. It's sort of like the main class. And then the controller interacts with the model and the view. A typical way of imagining how these classes interact with each other is the user will click on somewhere on the screen. The controller knows the XY coordinates where the user clicked. And so the controller might ask the view, do we know what actual grid location they clicked on based on those XY coordinates? And the view might tell the controller, yeah, they clicked in row 5, column 4. And then the controller might ask the model, hey model, do we know what game piece is located at row 5, column 4? And the model might say yes, and then the controller might tell the view to change something else. So that's the way the interaction happens. Usually the model and the view don't interact with each other directly. So in our project here, the display class is the view class that we're using. It controls how things look to the user. The game board class is the model class that represents all of the data and gives us methods for changing what the data is. And then we have 2 controller classes, each of the ones starting with run. So run graphical game is a controller class because it handles the user inputs and interacts with the view. And then run text game is also a controller class. Let's look in a little more detail at the run graphical game controller class. So we've got 2 objects that we can use here. We've got the game board object and we've got the display object. So whenever you want to know anything about pixels on the screen, you'll run a method on display. Whenever you want to know what's the current state of the game, or whenever you want something in the game to change, you run methods on the game object. Here in setup is sort of like your constructor. It's where we're initializing everything. So you can see that we're creating a new game board whose width is 5 and height is 5. And this is not 5 by 5 pixels. That would be very small. This is 5 grid squares by 5 grid squares. So it's really the size of the game board that we want to be able to play on. Then we create the display object by running the display objects constructor. We give it an X and a Y and a width and a height, and these are in pixels. So as you can see in the comments up here, the 1010 is the upper left hand corner of where it's going to display on the screen, and the, alright, well I'll change this by the time it gets to you, but this width and height are the actual pixel values for the width and height for how we want it to display. I would definitely encourage you to play around a little bit, change these numbers and run it and see what effect it has on the overall display. The last thing we initialize inside setup are the colors that we use for the display. So on lines 20 and 21, we're telling the display object to associate a particular color with a value that it might see in the game grid. because the game grid is a two-dimensional array of ints, we have int values here. So whenever we put a 1 into the two-dimensional array, the display is going to choose to display that as a red box. And whenever it sees a 2, it'll display it as a green box. If you want to, you can use images instead of colors. Actually, why don't I go ahead and illustrate that? So we'd comment out these, and instead, well, this is another thing I'm going to fix before I get to you. You have to use the actual correct name for your object. So instead of setting a color to be associated with each piece, you can set an image. Oh, this is also wrong. As you'll see in just a second, we have an assets folder here. And inside the assets folder, I've already put an off and an on.png. So on.png and off.png. And now when we run the game, instead of it displaying as a colored box, you'll see it displaying as, oh, it's running the text game. You'll see it displaying as a little image, which is not a very good image. I made this quickly, but you can replace this with your own images. The last two methods to understand are draw and Mouseclicked. If you remember, draw is running all the time in a loop that runs about 30 times a second. So you put things inside draw that you want to be updating all the time. For us, all we do is wipe the backgrounds, and then we tell the display to draw the grid. And we get the grid from the game. So this is a great illustration of this idea where the controller is telling the view to display something to the user, but it needs to display the current state of the game, which is information inside the model. So the controller first asks the game model to get the grid, and then it hands that grid information over to the view to do the displaying. This is pretty typical. So one more time. Game is our model, and we're asking the model to show us what the grid looks like. And that's the input to the draw grid method, which is the view. So that's what actually displays the grid. Mouse-clicked is what runs automatically whenever the mouse gets clicked in the window. And this is where we decide how to handle the mouse clicks. So what's happening in here is we're asking the display what grid location we clicked at using the mouse coordinates. And it returns a location object. The location object has a lot of methods, but the two that we care about are the row and the column. So I immediately ask what row and column, and then I tell the game that I'd like to make a move at that row and column. And then it's up to the game to decide, is that move even inside the bounds of the grid? Is the move a valid move for the particular player that's trying to go? So I let all the logic about how the game works reside inside the model class. You probably won't need to change anything inside this controller class. I just wanted to show you what's running. The display class I mentioned was the view. It controls how things look. You definitely don't want to edit anything in this file. So all of your programming is going to happen inside the model class, which is GameBoard. So let's take a look at the important parts of GameBoard. At the very top, we've got this two-dimensional int array called grid. This is where I create the variable that could be holding the 2D int array. Inside the constructor is where I actually make the int array. And the reason why is because the constructor is what handles the input information about what size the game board should be. When I first declare the class here, I don't know how large a game board I want. So we have to wait until the initialization inside setup, where I run the constructor with game board width and height 5 in order for these to have a value. And then I want to use those values to construct a new 2D int array and assign it to grid. So however you want your pieces to look when the game first starts, those initializations need to happen here in the constructor, because that's the job of the constructor, is to set things up at the beginning. So you may have noticed when I ran the game that there was a piece in the upper left-hand corner. That's because of this. If I was to set this back to 0, and then we were to run the game again, you'll see that there's no piece in the upper left-hand corner anymore. So if you want the game to start with a piece in the very middle, for example, or the entire top row filled, you could make those initializations here. You may remember that in the controller, whenever someone clicks a mouse, the last thing that happens is we tell the game object that we want to make a move in a particular row and column. So that's this method called move, and row and column are the requested place where the person has clicked and wants to move. Right now, the only thing inside this method is printing this debugging info so that you can see what the values of row and column are. But what you want to do is add your own code here that first checks if that row and column is a legal place to move, and then changes the game grid in whatever way you think is appropriate. For our particular game, that's going to involve changing these numbers from 1 to 2 or from 2 to 1 to turn the lights on and off. But in a different game, you might want to do other things. You'll need some way of deciding whether or not the game is over, and that's the purpose of this method, is game over, which returns Boolean for whether or not the game is over. For our grid game, for our game, turn off the lights, the game is only over when all of the lights are off. So what you would probably want to do is loop over every location in the grid, and if you ever see a light that's on, you know that the game isn't over yet. getGrid is just a getter method that returns the grid. Remember, we use that in order to hand the grid to the display object. And then the last method is sort of a helper method that I thought might be helpful. You may have seen when I ran the game that it's possible to click outside of the grid. So I might click here and it says you clicked in row 2, column -1. Inside the game board, if you tried to make a move at that row and column, it would go out of bounds because column -1 is not a valid location for the grid. So that's something that you would have to check here inside the move method. You need an if statement that tests to see if this and that location are out of bounds. Sometimes it's nice to keep your code clean and separate though. So the reason I included that helper method in case you want to use it is so that you can do something like this. You could say if is in grid row column equals true, then you can do your move. Or maybe what's even better is you see if the row and column that you were passed as an input is not in the grid, then you can immediately return false. And when you return false, you exit this command immediately. So what that means is that if you were going to change the game board down here in order to make a move, the fact that you've returned means that you're never running this code down here, so you'd never actually make the move. So really you're saying, if the move isn't in the grid, then exit with a value false, meaning that we couldn't make the move. So this isn't going to magically work. You actually have to fill in the inside of the isInGrid method down here, where you would return true if these coordinates were actually in the grid, and false if they're not in the grid. And that's it for the grid game framework. Come back next time where I'll actually illustrate with some code, like a very, very basic, it's not even a game, but I just want to show you how to make some of this stuff actually do things. And then it will be up to you to make grid game turn off the lights.